Okay, welcome to today's class. We are going to look at the area of a sector. Area of a sector. Area of a sector. So this is our topic for today. We're going to remind ourselves on the area of a sector. That is from 1 And a sector, we can derive a sector from a circle. Have a look at this. Let's say this is center O, then our radius R, and then this is angle theta. So a sector is this part of a circle that I'm going to shade, this shaded part of a circle. Now this is what we call a sector. As you can see, this is how it looks. This is theta, this is R. So we have this this is what we call now a sector. Now we're going to look at how to calculate the area of a sectors. Area of a sector. Good. Now, taking the area of the whole circle, the area of the whole circle is pi r squared. That is the area of the whole circle. Now to find the area of a sector, we take theta, the angle theta, divided by 360 degrees times pi r squared. That is the area of a sector. Divided by 360 degrees, then we multiply by pi r squared. So we can look at one example, 2 or 3 on the same. We have this one. A sector of a circle of radius 3 centimeters if the angle subtended at the center is 140 degrees. Now we are given pi, to take pi as 22.7. We are asked to take pi as 22/7. So the question is easy. Is asking us to find the area of a sector which is having a radius of 3 centimeters and subtending an angle solution. So under solution, first of all, you have to know the formula. So the formula is over 360 degrees squared. That is the area of a given. The unknowns. Therefore, we have to find the area. Now, therefore, the area will be 60 degrees times theta. We are given 22 over 7 times r squared. That is 3 times 3 or 3 squared. Now, when you or multiply 140 divided by 360 times 22 over 7 times 3 squared, you're going to get your area as 11 square centimeters. Now that is now your area of the sector. The area of the sector. So it's that simple. You simply substitute the given values to the unknowns, then you work out. So with that is easy. Now let us look at how you can find the radius when you are given the area and the angle. Then you're asked to find the radius. Then you're asked to find the radius. That one brings us to example 2. Example 2. And the question reads, the area sorry, the area of a sector of a circle is 38.5 intended is at the center. The center is 90 degrees. Then we're given take pi to be 22 over 7. Take pi to be 22 over 7. Solution. Now, we are given the area as 38.5 square centimeters. Then we are given the angle. Now we are asked to find the radius of the sector. So with this, the area is 38.5 square centimeters. Then the angle, which is theta, equals to 90 degrees. Then we are asked to find what? The radius. So we don't know. 360 pi r squared 0.5, which is equal to theta, which is 90 out of 360 times 22 over 7, which are not given. So we therefore have to find the value of r squared. So we have r on this side. So to remain with r on one side, we have to multiply by the reciprocal of each on both sides. Therefore, we are going to get r squared as 38.5 times now the reciprocal over each. So we shall have 360 divided by 90 times 7 over 22. That is 38.5 times 360 times 7 divided by 90 times 22, we're going to get our r squared as r squared is going to be around 49. R squared equals to 49. R squared 49. So having r squared as 49, we can value of r, and the value of r will be the square root of 49. And r square root of 49 is 7. So we shall have our radius as 7 centimeters. 7 centimeters. That is how easy it is. You can see the workings very clear and short. So that is how we do it to find the radius sector. So you shall look at more examples on that. Therefore, look at another example when you are given the area, you are given the radius, and you are asked to find theta, the angle subtended. You are asked to find the angle subtended. Now, let us look at this example. Let's call it example 3. This was 2. Now let us look at example 3. Example 3. Now 3 reads the area of a sector of a circle, of radius is 4,158 square centimeters. Now calculate the angle subtended. The angle subtended at the center of the circle. Now take pi to be 22/7. Take pi to be 22/7. Let us look at the solution for this. We are given the area, center of the circle. Now we are going to find the value of theta. The value of theta over sector is theta over 300. To get theta, we are going to reciprocal of r squared over 1. Therefore, we shall a times theta, 360. So we shall have a times a times 360 times 360 divided by pi r squared. So that is how we're going to find our theta. So area we multiply by 360 and then we divide by pi r. When you substitute or you find the value of theta, you're going to get area times 360 degrees of theta, which we are saying that theta area times 360 divided by pi r squared. So we shall have this 4060 degrees, 360 degrees. Then we divide with theta, 63 times 63 something. Now using your calculator, you can multiply 41, 58 times 360. Mine, let me use mine. So 41, 58 times 360, and you get something like 1,296,880. Now divide by 22/7. 22/7 times 63 squared. So you get 12,474. Now when you now divide, so that is 1,406,880 divided by 12,474. You're going to get 120 degrees. 120 degrees. Now that is now your answer, or your theta. So the angle subtended, as we've shown it here, is a 4158. Radius is that. Now out of 360 times 22/7 times 63 squared. So I get the same answer. I'm getting the same answer. That means my theta is correct. So my theta is correct, and that is the answer. So it's that simple, getting what the theta for your answer. Now, having that, you can look at another example. Let us call it example 4. Let is example 4. Now you can write the question. The shaded region in the figure below, shows the area swept out on a flat windscreen by a wiper. The area of the region. Let us look at this. Sorry. I think I don't see. just draw a sketch. I'll draw a sketch on that. So that one point screen, something like that. Then we have something like that. And then sorry. So I have this from here to here, and then from here to here. So we have 4 centimeters. Then we have 16 centimeters. So this is now the shaded region. This. That is the shaded region. This is just a sketch, not very perfect, but a area of the this shaded region. That is now the area they want us. Good. Now, when you look at this one keenly, you will realize that we've got the bigger one, and then we have the smaller one. So we have the bigger one, and it extends from the starting point. That is, and then it takes 16 centimeters. Then we have extra 4 centimeters. Therefore, a radius of 20 centimeters. That is 16 plus 4. Then it subtends an angle of 120 degrees. This is now another one, a smaller one, still subtending an angle of 120 degrees, but the radius reduces. It only moves 16 centimeters. 16 centimeters. So we have 2 sectors here. Now, to find the area of the shaded region, we're going to subtract the area of the smaller sector from the area of the bigger sector. Now, the formula for calculating the area of a sector is theta over 360 pi r squared. Region is equal to the bigger sector the area as theta over 360 degrees times pi. We have the bigger R now over 360 degrees R of the shaded. Now, common theta. Therefore, we have 120 degrees divided by 360 degrees times theta. We are taking 2 over 7 times the bigger R, this one. You said it's 20 centimeters. So we shall have 20 times 20 minus the whole of these minus 120 divided by 360 times 22 over 7 times 16 times 16. That way. Now, Working this out, that is 120 out of 360 times 22 over 7 times 20 squared, getting 419 419.0476. Now minus 16 squared, and you get of shaded region. The area of the shaded region becomes 150.8 simple. So that is how we arrive at the area whereby the wiper moved. The wiper. Another more example on the same. One more example on the same. That was example 4. Let us look at example 5. Example 5. And the question is the length of a minute hand of a clock 3.5 centimeters. Find the angle it turns through it sweeps an area H. So 4.8 take pi to be 22 over 7. So the length of a minute hand of a clock is 3.5 centimeters. Find the angle it turns through if it sweeps an area of 4.8 square centimeters. So this one is easy. Area of a sector, theta over 360 degrees times pi r squared. Therefore, they want us to find the angle, and therefore we say that theta is equal to, when you substitute the value of theta, or find, or we make theta the subject, we are going to find that 360 degrees times the area divided by pi r squared. Therefore, we are going now to substitute. Now we are going to take 360 degrees times the area, which is 4.8 square centimeters. R, the radius. Our radius is 3.5. 3.5. Therefore, when you calculate this one out, when you calculate and find the value of theta, you're going to get 6 17 of 28, then we divide it by 38.5. Then, therefore, our value of theta becomes 44.88 degrees. So this is now the angle. These are a minute hand moves or makes for it to cover an area of 4.8 square centimeter. It moved at an angle of 44.88 degrees for it to make that 4.8 square centimeters. That is how simple it was. That is how simple it was. So let us look at the very last example on this. The very last example. That is example 6. So 6 examples will be enough for this. So let us look at the last one. So you have example 6. We are saying the two arms of a pair of divider the two arms of a pair are spread so that the angle between so that the angle between them is 45 degrees. Angle between them is 45 degrees. Find the area of the sector formed. Find the area of the sector formed. Sector formed if the length of each arm is 8.4 centimeters. You can take pi to be 22/7. Take pi to be 22/7. So the two arms of a pair of divider are spread so that the angle between them is 45 degrees. So find the area of the sector formed if the length of each arm is 8.4 centimeter. So let us look at the solution for our last example. We have area as a theta over 360 pi r squared. So let me sketch it. Theta, that is 45 degrees, divided by 360 degrees times 22/7 times r squared. So s is 8.4 times 8.4. So when you work this one out using your calculator, you're going to find that the area that is going to be formed by the pair of divider is going to be 27.72 square centimeters. 27.72 square centimeters. That is now your answer. Very short working and clear. So that is all about the set is from one work. Uh, that is operations are done. And that is the formula. You can use the formula to find the radius. You can use the formula to find the area. You can also use the formula to find the angle of theta. So that one brings us to the end of our today's lesson. I hope you've enjoyed and you've got something for your future workings of mathematics. So have a nice time. We shall meet next time. Thank you.